Welcome to solverfy.
So, to find out the empirical and molecular formula of the substance, we will follow some simple rules or steps. So, the first step here is we will consider the given percentage of each element as mass in gram. So, we are given the percentage of carbon and hydrogen, and from there we can find the percentage of oxygen. So, we will do that and we will convert each percentage amount as their mass in gram. Then we will determine the number of moles of each element. Then we will divide each number of moles by the smallest number of moles to get the simplest whole number ratio of moles. Then from the simplest whole number ratio, we will determine the empirical formula of the substance. Then we will determine the empirical formula weight, and then from there we'll find the ratio of molecular weight and empirical formula weight, and from that ratio you will find the value of n with which you will be able to determine the molecular formula of the substance. So start by considering the each percentage as mass in gram, and before that we will find the percentage of oxygen, which will be 100 minus the sum of the percentage of carbon and hydrogen, 77.87 plus 11.76 percent, which will give us 10.37%. So now we know the each percentage of element. Now we'll find, and now we'll just consider each percentage as their mass in gram. So the mass of carbon will be 77.87 gram. Mass of hydrogen will be 11.76 gram, and mass of oxygen will be 10.37 gram. Now we'll find the number of moles for each element, which we can do by just dividing their mass by the molar mass. So number of moles of carbon will be 77.87 gram over the molar mass of carbon, which is 12.01 gram per mole. It will give us a value of 6.48 mole. Then the number of mole of hydrogen will be 11.76 gram, which is the mass of hydrogen over the molar mass of hydrogen, which is 1.008 gram per mole, and it will give us a value of 11.67 mole. Finally, the number of mole of oxygen will be 10.37 gram over the molar mass of oxygen, which is 16 gram per mole. It will give us a value of 0.65 mole. Now we will divide each number of mole by the smallest number of mole, which is 0.65, to get the simplest whole number ratio of moles. So the ratio for carbon will be 6.48 over 0.65, which will give us a value of 9.97. But we are looking for whole number ratio, so we will consider this 9.97 as approximately 10. Then the ratio for hydrogen will be 11.67 over 0.65. So all of these are mole. and it will give us a value of 17.9, which we can consider as 18. And finally, for oxygen, it will be 0.65 over 0.65, which will give us a value of 1. That means the ratio here is 10 is to 18 is to 1, and that means the empirical formula will be C10H18O. Now to find the molecular formula, so the molecular formula of this empirical formula will be a round bracket and an n over the bracket. So you have to find the value of n, and the value of n is equal to um, molecular weight over the empirical formula weight. So the molecular weight of this substance is given as 154 AMU, since a mass spectrum of this substance shows a peak at about 154 AMU. So we can consider that the molecular weight of this substance is 154 AMU. Now we have to find out the empirical formula weight. So the empirical formula here is C10H18O. That means the empirical formula weight will be 12.01 times 10, which is for carbon. Then we will have 1.008 times 18 for hydrogen plus 16 for oxygen. And this will give us a value of 154.24 AMU. So we just replace the value here, 154.24 AMU, and we will get a value of 0.998, which is approximately 1, as the value of n should be a whole number. So now the value of n here is 1. That means we can write C10H18O whole bracket 1, which will give us the molecular formula as same as the empirical formula, which is C10H18O. So this is our molecular formula for this substance. So both the empirical formula and the molecular formula for this substance is C10H18O.